So picking where we left off from last class, we were talking about graphing circular functions. Okay, those were your sine and your cosine functions. We did your basic ones. Actually, we did them using your calculator before, and then we reviewed how to do them graphically, applying your different types of transformations, like moving up, moving down. We did the simple ones in class on Wednesday. Now we're going to do the more complex ones today in class. Okay? So what you see on the board is y equals a sine b, parentheses x minus c plus d, and you also see it for cosine, and these are the general forms for writing a circular function. A represents the amplitude of your circular function. And amplitude basically represents the vertical distance between a max and a midline to a minimum. It is found algebraically by taking the maximum value, subtracting it from the minimum value, and then dividing by 2. That's how you find it algebraically. B represents the number of cycles between 0 and 2 pi, or 0 and 360. Okay, and a cycle is nothing but a basically part of the graph before it starts to repeat itself. Okay, because these are wave functions, periodic functions. They're going to repeat each other after a certain amount of time. And so B represents the number of times it repeats itself between 0 and 2 pi. It's also used to help you find your period. C represents your horizontal translation of your graph, whether you move the graph to the left or you move it to the right. It's also called your phase shift. And then D represents your vertical translation, which causes your graph to move up or down. Okay? Algebraically to find this, you would do max plus min divided by 2. If you ever had to potentially write the graph or anything like that, which we will be doing today. Okay? So your A and your D affect your Y's of your graph, and your B and your C affect the X's of your graph. And by X and Y, I mean the actual coordinates themselves. Okay? So, one last kind of formula to add in there goes along with the B. Okay? Like I said, B represents your number of cycles in between 0 and 2 pi. It is also used to help you find the period of any circular function. We use 2 pi over B when we're dealing with sine and cosine, but for tangent, what's the period for tangent?
1 over 2.
What's the period for tangent? It's pi. It is pi. So then to find the period for tangent, because tangent has a different period, it will be what?
Pi over B.
Pi over B. Okay? Still only 2 people, but that's okay. See how today is going to go. All right, here we go. So, what you see in the next few slides are just some examples of the different types of transformations that can affect sine, for example. This first slide, the first graph, it gives you the graph of sine. In the second graph, it shows you sine of 2x on top of sine of x. This 2 right here represents what variable? A, B, C, or D?
B.
It's B because it's attached to your variable. The B tells you the number of cycles you're going to have between what 2 values?
0 and 2 pi.
0 and 2 pi. And as you can see, you have 1 cycle, 2 cycles in between 0 and 2 pi. You can also use that to find the period of just 1 cycle. What's the formula to find the period? 2 pi over B, and B is 2, so what's the period? Pi. And as you can see here, it completes 1 cycle between 0 and pi. Very good. And then down here in the last graph on this slide, in the red, you see sine, parenthesis, 2, parenthesis, x over pi, x plus pi over 3. What does the pi over 3 represent?
C.
C. In words, not The horizontal translation. So this graph moved which way, left or right? Left, pi over 3 units. And as you can see, the starting point is no longer at 0, 0 is now to the left, and that is going to be pi over 3. So everything was shifted over. Yes? Transformations haven't changed from when we talked about them at the beginning of the functions unit, nor have they changed since last year. Here's one of tangent. Remember, tangent is the graph that has the asymptotes involved. Okay? What is the period here for tangent based off of the equation? Pi over 2, very good, because remember, for tangent is pi over b. B is 2, so your period is pi over 2. And on top of that, not only have we changed the period to be shorter, horizontal shrink by 1/2, but we've also have shifted it what way? Right, by pi over 4. Okay, so again, the horizontal translations and the b affect your x's, hence why only the x's were changed and none of the y's. It wasn't shifted up nor down. Yes?
How does I assume that's the amplitude of 2, how does that affect this graph?
You're talking about for tangent?
Mm-hmm.
Now the 2 actually is not the amplitude here for tangent. It actually is the b value because it's on the inside of the parentheses with your variable. So anytime the number's on the inside, it's going to affect your x's. And that's what causes our period to shrink. Now as for tangent, does tangent have an amplitude? No, tangent does not have an amplitude because there's no like high point or low point in tangent. The range for tangent goes from negative infinity to infinity. So if there was something that was going to affect the graph of tangent in a vertical stretch fashion, then there will be a number in front of tangent, like so. It would make it a little bit more stretched out, but it's still going to go to infinity. It's just going to be skinnier. But there would not be an amplitude. So if it asks you what's the amplitude of this function, and I'm missing an n in tangent, but if it was asking you for the amplitude here, what would you say? It would say none, because tangent doesn't have amplitude. That value affects the vertical stretch of the graph.
Why would you not say negative infinity to infinity?
Because amplitude is a vertical distance.
Oh.
Yeah, between that midline and a high point. But since there is no high point, it goes to infinity. You wouldn't say that, okay, the amplitude is infinity. You wouldn't say that.
Do the asymptotes also move pi over 4?
Yes.
They move, okay.
Yep, even the asymptotes will move as well. So everything will shift. Other questions? Okay. So we are going to graph a few functions together. Now I want you guys to try one on your own. We're going to sketch the graph of 5 cosine 2/3 x plus pi over 2 minus 2. There's a lot happening to the graph of cosine. There's a lot happening. Let's describe the transformations as a review of the functions unit. And then we'll see how they affect the original points for cosine. What does that 5 mean, description-wise? Vertical stretch by a factor of 5. Very good. What does the 2/3 mean?
Horizontal stretch by 1 over that value.
Horizontal stretch by 1 over that value. So it's what? 3 over 2. What does the pi mean? Left pi units and then down 2. Okay? So we have 4 different transformations that are happening to the graph. Which ones affect your y's, Brock?
Which ones affects the y's?
Yes. Is the 5, the 2/3, the pi, or the negative 2?
The 5 and the...
Brock.
The negative 2 and 5.
The negative 2 and the 5. Very good. And then, so that leaves 2/3 and the pi to affect your x's. So, the x's, they always get multiplied by 1 over b, and you'll always add or subtract your c. You'll always add or subtract your c. Your y's, they get multiplied by a, and you're either going to add or subtract your d. And I say add or subtract because depending if it moves left or right or up or down, that's when it's going to be plus or minus. Okay? So, which x's are we talking about? We're talking about the angles of the cosine function. Okay, and we only look at 5 of them. We look at 0. We look at pi over 2. We look at pi, 3 pi over 2, and we look at 2 pi. The reason why we look at those is because the corresponding y coordinates for the cosine function are nice numbers. What's the cosine of 0? 1. What's the cosine of pi over 2? 0. What's the cosine of pi?
Excuse me?
Yes.
If Christiana.
Cosine of 3 pi over 2?
0.
And the cosine of 2 pi? 1. Okay? That's why we use those 5, because they give us nice values back. Okay? So we're going to multiply all of our x's by 1 over 2/3, which is what again?
3.
3 over 2. And then we're going to add or subtract our c. Which one? Subtract our pi. And it's subtraction because we're moving to the what? We're moving to the left. So in order to get that, that means you have to subtract those values. So at this point, it's just a little bit of algebra. 0 times 3 over 2. Then minus pi.
Negative pi.
Okay. Then we're going to multiply this one by 3 over 2. So that becomes 3 pi over 4. Then what's 3 pi over 4 minus pi?
Negative pi over 4.
Negative pi over 4. Good stuff. Pi times 3 over 2 becomes 3 pi over 2. What's 3 pi over 2 minus pi? Pi over 2. 3 pi over 2 times 3 over 2 becomes 9 pi over 4. What's 9 pi over 4 minus pi? And then 2 pi times 3 over 2 becomes 3 pi. What's 3 pi minus pi?
2 pi.
2 pi. So then these become the new x values that you're going to plot with their corresponding y's. Let's get the corresponding y's. We're going to multiply y by what number?
5.
And now we're going to add 2 or subtract 2?
Subtraction.
Because it went down. 5 times 1 is 5, minus 2 is?
3.
Keep going.
Negative 2. Negative 7.
Very good. And then?
3.
And then those are the points that you plot to get the actual graph of 5 cosine 2/3 x plus pi minus 2. Make sure that when you draw your curve, you only draw a smooth, solid curve. Don't trace back over it if you make a mistake. Don't try to shade it to make it a bolded line of any kind. Just one solid, smooth curve. Okay? One solid, smooth curve. Let's say you decide to use pen on your graph and you make a mistake. No need to scribble it out frivolously. Okay? If you make a mistake, nice and simple. Okay? And then just correct it. Huh? Yes, because you would keep going, of course. The midline is the line that cuts the graph smack dab through the middle. In this case, it would be y equals negative 2. It's always y equals d. And as you can see, if I were to draw on that midline, it does indeed cut the graph in half. The distance between that midline and a minimum point, or that midline and a maximum point, is indeed 5 units. So that supports an amplitude of 5. And if I start at negative pi and I go all the way to 2 pi, how many units is that? Negative pi to 2 pi, how many units is that distance-wise? 3 pi, so my period would be 3 pi, and that is supported by the formula 2 pi over b. I would have to keep, change, flip. Keep, change, flip. Oh, it was 2 over 3. All right. So as you can see, it is 3 pi. Questions? Let's look at the next one. 3 cosine 1/3 x minus pi over 6 plus 2. Describe my transformations. Zach, give me one of my transformations. Up 2. Vegas, give me another one.
Right, pi over 6.
Right, pi over 6. Kendall, give me another one. Vertical stretch of 3. Very good. And then the last one, Harley. So you gave me these 3 already. That is the B. But transformation-wise, is it a stretch, a shrink, a shift left, shift right? Correct. It would actually be a stretch because it's by a factor of 1 over that value. So you stretch it, and by a factor of, it'd be 3. And then it would be vertical, horizontal. Horizontal. Okay? So, how does that affect my y's? How does that affect my y's, Leah? What do I need to do to them? Very good. I need to multiply 3 and also do what to it, Eamon? My y's. Add 2. Very good. To my x's, I need to do what, Olivia? I need to multiply it by 3 because it's always 1 over b. And then, Samuel, what's the last thing I need to do to my x's?
Add by pi over 6.
Add by pi over 6. Very good. At that point, it just becomes algebra. Make sure you use your big 5. That's 0 pi over 2 pi, 3 pi over 2, and 2 pi. And then, since it is cosine, always be careful. Make sure you recognize which trig function it is, because it's sine, you would start with something different. Cosine of 0 is it 1 or 0? It's 1. Then it goes 1, 0, positive 1. It's a pattern. Everything's a pattern with these functions, okay? So we're going to multiply by 3 and then add pi over 6. Run it down. What'd you get?
5, 2, 3, 1, 2, 5.
Very good. And so from there you plot them. Yes, there are no labelings. Clearly, as you can see, you have pi over 6, 5 pi over 3, 19 pi over 6, and so on and so forth. On your homework, I'm just going to give you a blank space for you to do your graph. And so you can make, if you want to make those 5 marks where those values are and you label, that's fine. However, if it's an IB question, they give you a graph and it's already labeled, you are going to need to place them where they need to be placed. Okay? So, since this one is empty, we can just pretty much fill in. This is 0, clearly. Pi over 6, 5 pi over 3. It really doesn't matter as long as they're equally spaced out. And then, of course, I'm going all the way up to 5. Bless you. 2, negative 1, 2. Yes.
For the x values, you said it's multiplied by 3 and then plus pi over 6.
Mm-hmm.
Is that 3 from the 1/3?
Exactly. Because you do 1 over b. So then that becomes 1 over 1/3. So then you keep change flipping, and that's how we get 3. So you always multiply your x's by 1 over b, and then add or subtract your c.
Is 1 over b, is that from the period?
That's,
Where's that from?
since 3 is the horizontal stretch or shrink, remember from transformations, it was always 1 over that value. That's where it comes from. That's how it affects your x's.
Oh, okay.
Yeah. Yes?
When we draw the graphs, can we stop at the endpoints, or do we need to show that it continues down?
That's kind of a loaded question in the sense because depending on the problem, if it says between a certain range, then you would want to stop at that that endpoint. Start wherever it tells you to start and stop wherever it tells you to stop. Otherwise, like for your homework, I'm just going to actually give you one cycle. And so you just give me the one and you don't have to do any arrows or anything like that. Once I think I said one. I want you guys to try this one on your own. Be careful. It is a sine function, which means the y values are going to be a little bit different, but the x values stay the same. Okay? So go ahead and give this one a try. Ask your questions if you have them. In case you're stuck, remember you multiply all your x's by
Negative 1/2.
and so you're going to be negative 1/2, 1 over b. Then you're going to subtract pi over 4. Very good. What's happening to your y? Multiplying by negative 1 and then? Very good. So if you were stuck on that part, remember it's 1 over b, add or subtract c, multiply by a, add or subtract d. Keep going. All right, so what did you guys, from your big 5 of 0, pi over 2, pi, 3 pi over 2, and 2 pi. What did you get for 0? Negative pi over 4. 1 down, 4 more to go. What about the next one?
Negative pi over 2.
The one after that?
Negative 3 pi over 4.
And remember, I was saying, there's a pattern between your x's, right? You had a negative pi over 4, then you had a negative 2 pi over 4, then you had a negative 3 pi over 4, so the next one should be a what? Negative 4 pi over 4, which is a negative pi. And then the last one should be a?
Negative 5 pi.
There you go. Now, because this is a sine function, your y's should go, originally they should have gone how?
0, 1, 0, negative 1, 0.
So then once you multiply them by negative 1 and move them down 1, it became what?
Negative 1, negative 2, negative 1, 0, negative 1.
And then from there you just plot them negative here, 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 and there. And this is one cycle. This is one cycle. As you can see, the graph has clearly been shrunk. It has been moved. It has been flipped over twice. It's been moved down. Lots of different transformations, things that happen. Now, the one mistake I don't want you to make is on the last slide on the front page of your notes. Go to the front page of your notes. I mentioned it there, and I made a slight hiccup when I was doing it today. But if you look at the formula to find the period of a sine function, what does it say on the front page? Over the absolute value of b. In this case, b is negative. Okay? So you wouldn't say your period is a negative value. No, it's positive. Okay? So make sure that you always do the absolute value of b when you're finding the period. When it comes to finding the points, though, you keep the negative there because it takes care of the reflections for you once you multiply. Okay? Those two negatives, the negative on the outside means it was reflected over the x-axis. The negative on the inside means it was reflected over the y-axis. So two reflections. Okay? So what is the period?
Pi.
It's pi, because it becomes 2 pi over the absolute value of negative 2. Remember, absolute value changes a negative number to a positive. So then it's just 2 pi over 2. So your period is pi. What about your amplitude? What's your amplitude here?
1.
It's 1, because remember, amplitude is also the absolute value of A. So your amplitude would be 1. Okay? Questions on graphing? These are the more complex ones. The simple ones are simple. Move up, move down, move left, move right. Change the period. When we have multiple ones, that's when it gets a little involved. Let's write the equation. Sometimes you'll be asked to write the equation of the function. You have to, again, go back and refer to your knowledge of amplitude and period and the format. So we have to find the amplitude and the period for this particular graph, and then we're going to actually give the equation. Okay? These are some of the more simple ones. Actually, I pulled this straight from a pre-calculus book. Okay? This question is a pure calculus question. Now, as we get further, you'll see some IB type questions, but this is just to make sure to practice to see if you guys understand. When you look at this graph, what is the amplitude? 3. Okay? If you're unsure of how we got 3, remember the amplitude comes from the midline to a max or to a min. What's that distance? If you still can't see where the midline is, then you can always use the formula. What's the formula to find amplitude? Max minus min over 2. Your max is what? 3. Your min is? 2 negatives make a? Positive. And all over 2, so that's 6 over 2, which make 3. P stands for your period. What is your period here? 12. If you notice, it's a number. It is not like 2 pi or something like that. Okay? But it's from where it starts to where it ends. The cycle ends before it starts to repeat itself. Do I have a phase shift? No, I do not. Which equation would be easier to write, a sine or a cosine function for this? A sine function, okay? So I already know it's going to be y equals a number sine. Then I have b times x. And you said I don't have a phase shift, right? So then it's just going to be bx plus d. Do I have a d? I don't have a vertical shift. What's my y-intercept? 0. If I have a y-intercept at 0 and it's a sine function, there is no vertical shift and there is no phase shift either. What comes in front? 3. And then to find b, I would use the formula 2 pi over b equals our period, which is 12. So 2 pi over b equals the period. You would use that formula to find b. How do you solve for b? So this becomes 2 pi equals 12b. B equals pi over 6. That's what causes your pi's to disappear from the x-axis. Because you'll end up multiplying by 6 over pi, and then the pi's will end up canceling each other out. Then you get regular numbers on your x-axis. Let's look at the next one. We're going to find the amplitude, find the period, then give the equation. Amplitude, what is it? Try again. What would you say? Sorry. 0.5. Okay, sorry. I thought y'all said 0.25. My bad. Sorry. 0.5. What's my period? Pi over 2. You can always go from maximum to maximum and figure out what that horizontal distance is. And that's your period. Sine or cosine? Do I have a phase shift? No, because remember, on a normal graph of cosine, the maximum occurs at your y-axis, and the maximum does occur here, so we have no phase shift. Do I have a vertical shift? No. So again, I only have an A and a B. Okay? What's going to be A? 0.5. And again, to find B, you do your period equal to what again? 2 pi over B. How do I solve this? So this becomes pi B equals 4 pi. What is B? 4. And it's 4 because you divide both sides by pi. Question?
Why is the period pi over 2?
Because the distance before the graph starts to repeat itself is pi over 2 units. So from 0 to pi. So far, so good? Okay. Here's an IB question. Okay. Here's an IB question. I don't know how well you can see that graph, and it is kind of blurry up here. It's what happens when you copy and paste of a copy. So, the graph of the function is in the form of y equals p cosine qx is given for the diagram below. You have to find p and q.
P equals 30.
P equals 30 because P corresponds to what letter in our general form? A. And Q is what?
4. B.
It's technically B. And sounds like we already had an answer. You said 4? Okay. So P is 30 and Q is 4. What's the period here? And that's exactly how got 4. Cross multiply, technically it should be a Q. That's how you get it. Yes, this is an easier of an IB problem, but it's an IB problem nonetheless. How you feel?
So technically, could any graph be written as sine or cosine, depending on how you, like, because it could be more work if you do one or the other.
Correct. Question was, can any one of these functions be written as a sine or cosine function? And she was like, depending on, the amount of work to do, very much so, yes. Okay? In this particular case, it told you to write a cosine function, so you wanted the cosine function. But here, if I went back to this one, I could have asked you guys to write a cosine function instead of a sine function. The only difference is that you would have a phase shift. Okay? The phase shift is basically the horizontal distance to reach your maximum point. Because normally cosine has a maximum point at the y-axis, correct? Mm-hmm. But if it's no longer at the y-axis, that causes a shift in the graph. What is this horizontal distance to get to the maximum point? 3. So 3 would be the c in your equation when you write it. So you could have written the cosine function here, and it would have been 3 cosine pi over 6 x minus 3. And then that would have been your cosine function. So whatever that horizontal distance is to reach your maximum point, that is your phase shift. But the A, the B, and the D all stayed the same. Okay? Can you guys do this one on your own? Give it a try on your own? Give it a try. You're writing a cosine and a sine equation for this. To write a cosine and sine function for the following, I need A, B, C, and D. And A, the B, and the D are all the same no matter whether you're writing a cosine function or you're writing a sine function. Okay? So, let's figure out, actually that might be a minus. Let's figure out the A. What you guys get A to be? 2. Very good. Your max occurred at what y value? 0.5 or 1/2. And your minimum occurred at negative 3.5 or negative 7 over 2. Remember, you can always find your A by doing, what's the formula? Max minus min divided by 2. So we have 3 for our value of A. Very good. Let's go ahead and let's find D, because that takes care of the y's and deals with the maxes and everything. Okay? So, find on person. What you guys get for D? As in dog. The D is going to be the same whether it's sine or cosine. What's that vertical shift? Negative 1.5. So negative 3 over 2. What's the formula to find that? Max plus min divided by 2. Questions? Okay. B. The B is the same no matter what trig function we write, sine or cosine. What's the period? 4 pi. So that's 4 pi equals 2 pi over b. When I cross multiply and solve, what does b equal? Say again? 1/2. So b is 1/2. Two. Let's see. We have a question about the amplitude. What's the formula again for amplitude? Max minus min divided by 2. 2 negatives make a what? Positive. So 1/2 plus 7/2 is?
4.
It's 4. What's 4 divided by 2?
I think you said.
Wait, we all said 2.
You all said 2?
Yeah.
And I wrote 3? Do you have a phase shift for a sine function?
Yes.
What is it?
Pi over 2.
Is it pi or is it pi over 2? Why is it pi and not pi over 2?
So it's like a quarter of the period.
It's a quarter of the period. Okay? So am I going to put a plus pi or am I going to put a minus pi in the formula? Do I have a phase shift for cosine? No? So, if I don't have one, that means that I just leave that as an x. I don't have to include a parenthesis, but I didn't know if I was going to have a phase shift or not. Questions?
How do you get the x minus pi again?
What did you say? How do you get the pi again? For the phase shift?
Quarter of the period.
It's a quarter of your period. Does that make sense, or does he need to elaborate on that?
Elaborate.
Can you elaborate, please?
Like from your max to your min, half of that would be where sine starts. Right? Yeah. Half of that would be where sine starts, and that's a quarter of your period. Which is pi.
I mean, I put pi too, but you did do a stretch on it, right?
You did do a stretch, yeah?
So what does that affect it?
Well, normally it would be at 0. And so we did stretch it, so it wouldn't change 0 at all. And we did shift it over. But by already taking care of that shift, and it is that starting point of 0, it doesn't affect that. Question over here?
How come cosine doesn't have a phase shift again?
How come cosine does not have a phase shift?
Because you didn't move it left or right.
Can I have one person respond?
It doesn't. Cosine doesn't move left or right because it's already beginning at the y.
What's beginning at the y-axis?
The maximum.
A maximum point. Whenever there's a maximum point on your y-axis, that means there is no phase shift. There's still something. Yes, question?
Would it be x plus pi because you're moving left and not right?
So would it be an x plus pi?
Yeah.
Yeah.
Okay, did you guys say plus or did you say minus?
We said minus.
You said
I think
minus?
some said
Start
plus.
of the graph.
Well, it starts at 0, 0, and then it goes
Or
to
some.
the first one.
There's a difference. If you are going to use this as your starting point, okay, that means that it would be an x minus pi, but you would have to make one adjustment to the equation.
Negative
Yeah.
2 sine.
It would have to be a negative 2 because sine normally starts up and then goes down. But if you start here, then technically it goes down like it's been reflected over your x-axis. But if you want to keep it positive and use this as your starting point, then this needs to be a what? A plus. Other questions?
For cosine, why is it minus 3 over 2 instead of minus 3?
Did you guys say 1/2?
No, that's just what I originally did.
That's what you originally had?
And I don't know how I got it. But
Okay. What's the formula to find D? Max plus min divided by 2. What does the numerator become?
negative 6
What's negative 6 over 2?
negative 3.
Other questions? Yes.
I'm sorry, I still don't get why is it plus pi? Like why?
Sine normally starts at 0, and then it goes up, and then it goes down, and it comes back up. Okay? If you're wanting this starting point that normally occurs at 0, 0, you basically need that point that intersects with the midline, which is either going to be this point here or this point here. Okay? Since each one of these points divides up your period into quarters, your starting point, this point in the middle, your minimum point, and so on and so forth. Since it does divide up your period into quarters, you just take your period and then divide by 4, and then you'll find out exactly that distance from the cosine value.
Okay.
And since cosine is already at 0, you would have to go that distance back. It's the same thing with this formula, this one right here. What was the period for this problem? And if you divide it by 4, what do you get?
3.
And that was the phase shift that took us to cosine.
Okay.
Other questions? Do this one. You're writing a cosine function. Y equals A. What was A? 8. Cosine B. What was B?
6.
It was 6. Is there a phase shift?
No.
So then it's just a 6x. Is there a vertical shift?
No.
No. It's good to know the both ways to figure out amplitude or vertical shift or even the period, especially in situations like this when you can't figure out, okay, what exactly is this value right here? But you know that B represents the number of cycles that occur in between 0 and 2 pi. How many cycles do you have in this picture? 3. And that's from 0 to pi. And since this is a periodic function and repeats the same pattern over a certain amount of time, that means there'll be 3 more cycles in between pi and 2 pi for a total of 6. Okay? That was good. You were able to identify those pi over 3? Oh, that's another way you could do it. You have pi. You have 3 cycles, so pi divided by 3. That's a good way as well. Over here, it tells you the form in which you need to write it in. Looking at this graph, what's the value of A?
3.
Careful.
Oh.
A is 2. Because what's the value of C? 1. The graph was shifted up. So even though the max was at 3, the minimum was at -1. So your amplitude was 2. B is what? 2. You have 2 cycles that occur in between 0 and 2 pi. Or on top of that, what's your period? Pi. And you said that equal to 2 pi over B and solve. And that's how you can also algebraically get the value of B. Questions on this one? Let's look at the next one. Let's go backwards. What's C? 1. It was vertically shifted up. Your max is at 2. Your min's at 0. You can do the formula there. What's the value of B? 2. You have 2 cycles that occur in between 0 and 2 pi. What's your period here?
-1.
Period?
Oh, pi.
Period's pi. So you can also do pi equals 2 pi over B. And you can solve and find out that B is 2 that way. And your A?
-1.
And why is it negative?
Because it's reflected over the x-axis.
It was reflected over the x-axis and then shifted up. Remember, sine normally goes up, then down. So if it starts to go down first, that means it was reflected over your x-axis. This one's on you. So, the graph of y equals a sine b x minus c. Part of the graph is shown below, and given that a, b, and c are positive, so they all have to be positive, you have to find the value of a, b, and c. What's a? What's a?
-4. Because it can't be negative.
It can't be negative, so a has to be positive. All of these have to be positive. Okay, so a is a positive 4. Okay, a is a positive 4. What about b? 2. Number of cycles that occur in between 0 and 2 pi. The period is pi itself, so you can set that equal to 2 pi over b and solve. Now the question, what's c? Pi over 2. Okay? Because when you go to plug it into this formula, that would be x minus pi over 2, which means you move which direction? To the right, which means that you'll start here. And yes, that is indeed sine. Questions on writing the equations of circular functions or graphing them? Yes.
So on this one, C couldn't have been pi.
C couldn't have been pi because then it would have started here and then it would have gone down, which would have made A negative and A had to be positive.
Oh.
But technically, if you had to write an equation and you didn't have the restrictions of them being positive, you could have done it, right?
Yes. If you did not have the restriction of A, B, and C, then you could have done a couple of things that I heard you all say. Other questions?